Hello and welcome to Marietta College's Geology 112, Historical Geology, Introduction to the Final Project. We have a final project that I've posted on Moodle, and your instructor should have posted on Moodle. It will be due next Wednesday at 5 p.m. This is the first part of a two-part final project. This first part is mainly going to be collecting data and learning how to display the data in useful ways so that later on it can be interpreted. The second part of it will be interpreting the data and using a geological map, cross-sections, and the other information that we're providing you to construct a geological history of the area in question so that you can make recommendations about where to drill for oil and gas. You're going to use that information to write a short paper that will be a lab report that will incorporate all of the information that you've been pulling together for this lab. So this week we're going to start out by introducing you to the data and to the area. It's a fictional area, and you're going to be a petroleum geologist that's charged with a job. Your job will be to go into an area that we're calling Bullseye County. We're going to supply you a map and fossil samples, as well as pages on which you can compile the information to pull it all together. And again, that's the hardest part of a project many times, is to actually get started pulling the data in and putting it in a format that you can actually look at it and make interpretations. So this is mainly what we're going to be doing in this first part of the project, and it's going to take a little while for you guys to do this. So let me introduce you to the area first by looking at our map. And the map is right down here. This is something that you've been supplied with, an area called Bullseye County, and you can see that the map has lines on it and little dots with numbers and letters next to them. Actually, mostly letters. There is a line cutting across like this, and then there are some squiggly circular lines. This is a geological map, so the lines on this are not necessarily contour lines, but they're the contacts between formations. What we're assuming, or what we're going to tell you, is that back in the 1960s, an oil company went out into this area and explored for oil and gas. They drilled a borehole, and it did not produce sufficient quantities of oil and gas to be completed, so they abandoned it. And that's what you can see right here. There's a little circle with a plus sign next to it, and that's the typical symbol for a dry hole. It says Tenneco BC number 1 TD 5350 feet. So it was drilled to a depth of 5,350 feet. And it sits right on this cross-section that you're going to construct next time. So don't worry about that for right now. But what we are going to worry about is, as soon as we get the samples for all of these locations here, we're going to identify them so that you can figure out the ages and the rock types for each of those formations. So then we can try to understand what the requirements are for a hydrocarbon accumulation and see if there might have been perhaps a better place that they could have drilled an oil and gas well in this area than the place that they drilled here. And you can tell us perhaps why that wasn't such a good spot to begin with. Okay, so let's get started, and we're going to look at the handouts that have been supplied to you on Moodle. The things that you've received on Moodle are, number one, a lab sheet that basically has all of the data tables in which you're going to put all of the information that you collect from the PowerPoint slides that have the samples on them. Unfortunately, since you can't be here in lab with us, you can't identify the physical fossils and rocks. So hopefully we've supplied you with enough information that you can adequately identify them using the resources that we've given you. So we have the main handout for the lab that you're going to fill with information. We've given you a map, and then on that same handout with the map, we also have a key that sort of has a bunch of different symbols that we're going to use for the rock types. Now I want to caution you first. We're not going to put those symbols onto the map. Those are the symbols that are going to help us populate these tables that are in the handouts. So do not draw these symbols on the map. We're going to put other important symbols on the map, such as signs for anticlines, synclines, strikes and dips. We'll actually write out the ages of the rocks, and we might write in the name of the rock type, but we're not going to fill our entire map with all of these pretty symbols. Again, those are for putting onto our measured sections and our composite stratigraphic column. So we're going to use those a little bit later, but you'll have those handy anyways. What you should also have access to is your identification key that you have been becoming familiar with throughout the semester. So you should recognize this. You used it last week too in your backwards biostratigraphy for the Grand Canyon. So make sure you have that handy as well. So all in all, there should have been this handout, a scan of the map and the key, the lab itself, and then there should be 2 PowerPoints that, similar to last week, we've supplied you with pictures of rocks and fossils that you're going to identify based on the information that we're giving you. So let's zoom into the first page of the lab so that I can go through the parts individually. So here's the beginning. It basically has a short discussion that you are going to go through a 2-week process in which you're going to gather information, compile it, and then you're going to make recommendations and interpretations about where to drill for oil and gas. You're going to be supplied with samples from surface outcrops that consist of fossils and rocks, and you're going to be supplied with samples from a wellbore that someone drilled in the southeast area of the county, and that's that well that I pointed out to you, the Potenico BC number 1. Those are going to be supplied to you on PowerPoint so that you can use the PowerPoints to identify the information. And you also have a graphic stratigraphic column that is farther down on the handout that I'll get to in a few minutes, in which we'll compile all this data and try to make sense out of it all. So the first thing that you have to do is identify the fossils and the rock types. And what you see is for each sample that was on the surface for the map, we have a column or a row for the samples and the rock, the fossil and rock samples, for you to record that information. So you should go ahead and do that. Of course, the rock types, where do you find those rock types? I've given you a huge hint, and my hint is by moving the camera, I'm going to go down to that key that I mentioned before for the map. Well, it's not for the map, it's for the measured sections and for the stratigraphic columns that you're going to be constructing. I've given you the possible names of the types of rocks, and hopefully from the pictures and some other hints that I've supplied in the lab, you'll be able to use that information to figure out what the rock type is. And again, use the hints that I've supplied in the PowerPoints to put in the appropriate information. Keep in mind, you have to put the rock type. So, for example, maybe rock type A might be a green shale. So just write green shale in that area for that column. And then there might be 3 fossils associated with that. And you guys know how to do this. Identify the fossil, write its genus name there. Don't forget to underline the genus name. And then write the age range in the next column. So that's what the next column says for range. So if the age range is Devonian to Silurian, write Devonian to Silurian in that box. You do not have to write down Upper Devonian to Middle Silurian. Forget the uppers and middles and lowers. We're just going to worry about the time periods themselves. Then once you've identified all 3 of them, let's say you have a fossil that ranges from the Devonian to the Silurian, you have a fossil that ranges from the Silurian to the Ordovician, and you have a fossil that goes from the Cambrian to the Silurian. Of course, the last column says what period do they all overlap in. So we're going to assume if they all overlap in one period, and they will all only overlap in one period, you write that period there. And in this case, since we had ranges that went from Cambrian to Silurian, Ordovician to Silurian, and then Silurian to Devonian, of course the Silurian is the overlap, and so that's what you'll put in that last column. Each one of these spaces only has count it, one period. It should not have a range. The ages, of course, if it is capital CY and then capital CX, those are from the same formation. So the formations are A, B, C, D, E, F, and G for the surface samples. And then each different formation, they might have been a couple places that they collected them on the map. So there's a BX and a BY. The time period for the last column, they should jive. They should be the same. Although the ranges and the different fossils might be different, the rock types should be the same too. Okay? So, one time period at the end, the rock type should be the same. In fact, for many of them, I might have put the same picture for the rock type in both BY and BX. Okay, but make sure you have all of this filled out. I have filled in one or two places where I had trouble finding things that were just like Jurassic. So there's a couple of them that have been done for you already. Now, do the same thing with the core. So the next column is basically the core log. So it's using that same type of information to figure out what the ages for all of these layers are that were encountered in the core. The oldest one, down here, number 1, that's the deepest. So of course think of number 1 being what happened first, and then number 9 being what happened last. Now, number 1 is the only sample that does not have any fossil samples. And that's because, of course, I'll give you a hint, they are granite gneiss. There just aren't any fossils in those. But I'm trying to lead you into figuring out what the age of that rock is. Now, there is right above it, the rock above it, I believe, will be a Cambrian rock. So this sort of hint right here that says pre with an arrow pointing upwards is supposed to be telling you that is pre-Cambrian. So write the word pre-Cambrian in there when you're done with it. Now at the very tippy top, layer 9 will have the youngest rocks. Of course, that's in the wellbore, the youngest rocks that are encountered in the wellbore. And you're going to do the same thing by figuring out what the rock type is, what the genus was. Don't worry about the depositional environment was. I forgot that that was there. All we're interested in right now is what the rock type is. So if number 9 is a coquina limestone, then write coquina limestone in here. You'll have the 2 genera to figure out their ranges, and then put the period in the final end there, in the final column right there. So again, you're going to compile that information just like you did for the previous surface samples. Now we're going to compile the data even a little bit farther. The first thing I want you to do is notice that I have at the top the different rock types that are the same rock types that are in the handout that I supplied to you earlier. Here's that handout, and what I really want you to do is take the patterns that are in here and then put them into these different columns so that you'll have them handy for you. And that's just part of what we want you to do. We're going to have you hand in each of these pages, 1, 2, 3, 4, 5, that you've written on in the end, as well as the page that's the map. So there'll be 6 pages, at least 6 pages that you're going to turn in by emailing it to Frank by next Wednesday night. Now once you've done that, you should go into each of the layers from the measured section, A, B, C, D, E, F, and G. Write down the age in the final column first. Now one thing that you'll notice is in these measured sections and in the core log that we're going to complete next, there's a squiggly line right in here. Now because of my printer or because of the way that the PDF did not properly come through, it just looks like a weird bunch of dashes right in here. But I want you to take a pencil and make that into a squiggly line so that it actually looks like an unconformity, because that's what that is. So take your pencil and make a squiggly line just like that for each of those, and make them go all the way across too. Different people's word processors might have that print out in a slightly different way. So you guys go ahead and do the same thing for all of those, and those lines should go all the way across. Yes, those are unconformities, and we'll be describing what those are fairly shortly. So basically, what I want you guys to do for these is take the data that you have in the previous paper areas and put them over here. So for basically age, if G is Eocene in age, write down Eocene in age there. And then in this spot, you're going to write down the symbol that is associated with this rock. And if it happens to be coquina, you will see that there's a symbol for coquina limestone on your handout that you've been supplied with. So put that in there and go on down that list until you fill them all in. Now, do the same thing with the core log samples, for the core samples, and you shouldn't expect that the adjacent rows are going to be exactly the same, because there are different layers in the core than there are on the surface. And you'll realize later on why that is. So because the wellbore did not penetrate all the layers that are present on the surface of the map. In fact, in some cases it penetrated more because it got down to ancient rocks like the Precambrian. So let's put Precambrian here. And then here you'll write down the pattern for the Precambrian rocks, which were gneiss and granite. So this is going to be a nice graphical way for you guys to walk into your boss and show your boss, him or her, right away that these are the rocks and these are the samples and these are the ages of the rocks that we found within our study area. Then I want you guys to step over to the next handout right here. And this one is going to be a little bit more confusing to you, but I need to explain it to you right away. Now focus first on the two charts, the two tables that are on the top of the page. Now these aren't going to be real important in the end, but I'm using them for now to get you guys to understand that some of the layers within the wellbore and some of the layers on the surface correlate with one another. And what we want to do is figure out which ones are equivalent with the other. And for just a start out hint, what I will tell you is just go ahead in each of these and write down the age. So for number 1, remember that was the one way down at the bottom, granite and gneiss, that was the Precambrian. I'm just going to put Pre-C in there because I didn't give myself enough to write the whole thing down. And what I'll tell you right away is that there was not any Precambrian on the surface. So if you look over there after you fill in this side with the ages, so do that first, fill in the ages, you'll see that there's not a Precambrian rock over here. So what it says right here in the second row is to say it correlates to surface sample letter or none. And since there's not a layer that corresponds to the Precambrian on the surface that you found in the wellbore, you're going to write none there. Now on the other hand, layer 9, if that happens to be Eocene, what you might find out is there might be an Eocene of the same rock type that is in each of the data sets. And so for number 9, we might actually write, okay, if we find out that Eocene, this coquina, is present in both data sets, I'm going to write here that for number 9, that Eocene rock has an equivalent in the surface samples that was G. And for G, that was the Eocene rock, it's equivalent to 9. So go ahead and try to figure that out for all of the different samples that are in there so that we can compile that data a little bit more. Again, in the end, we're not going to use that data except to try to fill in these numbers and letters so that you sort of understand what the composite stratigraphic section is. So focus on that now. This page at the bottom is a composite stratigraphic section where we're going to take all of the information that we found in both the core and both the surface samples, and even though we didn't see all of the formations in either one of the data sets, we want to give a summary that contains all of the layers that are present within Bullseye County as we mapped it, whether it's in the subsurface or whether it's on the surface. So this is sort of like a summary of all of that stuff. Now again, the first thing I'm going to do is I'm going to fix my squiggly line right here. This should be a squiggly line that goes all the way across, that is that unconformity. So you can see that there are 3 unconformities in here, and that should become more and more plain as soon as we get to the map. Now, again, this is going to be a summary graph that shows us, a summary table that shows us all the layers that are present. Of course, how do we figure out what goes on the bottom? Well, you guys remember, oldest on the bottom, youngest on the top. Once you have it all figured out, you will realize that the number that's the oldest rock, of course, is number 1, which is Precambrian, that is granite and gneiss, and this one is actually plutonic. Now it's strange up here I say, what's the environment, terrestrial and marine? That's the only one that I didn't put in there, so write plutonic for that granite. Now, as I go up, I'm going to get up to, well, what's the youngest one? The youngest one might be that Eocene, and that corresponds to G and 9. So that's the same layer, that's Eocene. It is the coquina, and it is a marine rock. And little by little, I'm going to fill this in, and what you're going to realize is that there are a couple of layers that are in the surface samples that are not in the wellbore that you'll basically have to slip in there someplace. So what you should probably do is just go one at a time, 1, 2, 3, and fill in the things that are in the wellbore, and then as you get close to the top, you might realize where the 2 or 3 layers that are in the surface samples should fit. Hint, hint, E and F are going to fit in pretty close to the top there. But you can basically go by the ages, and since you guys know the geological time periods and the epochs very well, you should know what should come first and what should come last. So this is going to be a composite stratigraphic section that's going to be a summary stratigraphic section. Then you're going to talk about the 3 unconformities that are right here. Now I'm going to have you turn back to one of the pictures that's basically the map that you guys are going to be working with for this project. Once you've finished putting together your composite stratigraphic section and filling in all the columns and then describing the types of unconformities, I want you to look at your map. There are some instructions that are with your lab to help you through these different parts. That's the very last part of the lab. So it says make a composite stratigraphic section. Some of the things I mentioned were right in there. Find and name all the unconformities. This should help you try to understand which conformity is which on the composite stratigraphic section. And then the last thing I want you guys to do is complete the map. So you'll do a whole bunch of different things. Number 1, label the age of each formation, especially at the locations where we collected the samples. So for example, if A is a Pennsylvanian rock, write Pennsylvanian in there. If B is a Pennsylvanian rock, and it's okay, it's legal to have 2 layers that are the same age, what you might notice is that there may be different rock types and different fossils. Maybe they are both from the same period, but one is from slightly younger in the same period, but might have fossils that are, say, terrestrial instead of marine. So for now, you're going to put the name Pennsylvanian and then write in the rock type there. If the rock type is coal and graywacky and shale, then write that there. If the rock is fossiliferous limestone, write that there. Do that for each one of the formation layers, and then you'll have a little bit better idea of how to finish the rest of this map. So it says label each formation with its age based on the fossils collected. Label layer A through G with the corresponding rock name, and draw the axes of any structures. Now from your class in structural geology a few weeks ago, you might recognize a few structures in here. For example, right here. This one has an axis that goes right down the middle like this. And how do you draw an axis? Just simply like I did. Draw it all the way across the layer. Now, then you have to figure out what kind of structure is that. Is this an anticline or is this a syncline? How do you figure that out? Well, you have to figure it out based on the age relationships of the rocks. So if this is oldest in the middle, and as you go farther and farther out, the rocks get progressively younger, of course you remember that that means that this structure is an anticline. And if it is an anticline, the label that you write on it would be arrows pointing away from the center like that. And also, if you notice that these sort of curve around at the end because it's a plunging structure, if it was a plunging anticline, you would put some big arrows on the ends there that indicate that it's plunging, doubly plunging away from the center. That's if that's an anticline. Remember, if it's a syncline, you would actually have the opposite occur. You might have something that looks more like something I drew on the board a little farther over here. So this is what it might look like instead if you had a syncline instead of an anticline. Remember, for a syncline, the arrows point in towards the center. It looks like a little X in the middle, but those are actually 2 arrows. Now, the other thing I want you guys to do on your map is put a whole bunch of strikes and dips around your map. They don't have to be just strikes and dips at 1 or 2 places. You could put 100 of them in there if you'd like, but it helps you understand where the strikes and where the dips are. Now, one thing I want to make sure you understand is in the middle of this sort of oval is not the only axis of a structure. And what you'll notice if you go over back to the main map, let's turn it back to the map so that I can point out something on this map. I need to zoom back into it. If you go over here to this part of the map, you'll notice that F, layer F, is surrounded by layer E over here and layer E over here. And what that needs to make you understand is that even though it's not a doubly plunging structure like the one over here is, there's actually another structure that has the axis going right down the center. Now I want you to draw that axis, but I want you to stop it, boop, right there, because layer G is actually sitting on top of everything else. And I want to explain that too real briefly. So in this area down to the southeast of the map is an area that just says layer G, and that's in the same area that the wellbore was drilled right here. You can see the cross section going from J to Z is cutting across right here. What I want you guys to sort of imagine is that this line that's the boundary between all of the other layers and layer G, which is the youngest layer in your cross section or in your composite stratigraphic section, that's actually sitting on top of everything. So when you're thinking about what the types of unconformities are, think about layer G as if it's sort of a flat layer that's sitting on top of everything else. And when you get to the edge, you go down a cliff, and then you go across this eroded area that's actually, that layer that was G may have extended across the whole area, and maybe even more layers on top of that were there too. But now, only the part in the southeastern corner is where there is some of that coquina still present. So where they started drilling their well, they first had to drill through that thin layer of coquina before they got down to the layers below. So what I want you to remember is that when you're drawing the hinge of this structure right in here, whether it's an anticline or syncline, I don't know yet, you'll have to figure that out. Again, stop it right there. Now, if layer G is sitting there, what you need to understand is that if you could peel off layer G, these other layers would sort of continue under there. And next time when we're making our stratigraphic, when we're making our cross-section through the area, we'll explain to you how you can sort of draw in some lines to show what the subcrop looks like. But anyways, let's make sure that you guys understand that this flat layer sitting on all those tilted layers sort of tells us about what the unconformity is right underneath G. Well, hint, hint, when you have tilted layers below, like all of these anticline and syncline layers, I'm not going to say which is which yet, and then you have a flat horizontal layer of sediment above that, that would of course be an angular unconformity. Oh, I just gave it away. Oh, for goodness sake. So anyways, I hope that gets you started. If you have any questions, please feel free to ask me and Frank. Oh, the other thing I needed to tell you, there will be lots of different things that I don't want to forget about, is that you have to put strikes and dips. Remember, when you're putting strikes in, you just put a little dash that's parallel to the contacts, and then you have to figure out which way the rocks are dipping. In this case, I believe it will probably be like that, dipping towards the hinge axis in this particular structure. In this structure, they will actually be dipping away, especially if that is an anticline. So go ahead and put a whole bunch of strikes and dips all over the place here. Be very careful. I was a little sloppy right here. That one should not look like a Y. It should look like a right angle right in there. Now the symbol for horizontal layers, like the layer G is over here, is a circle with a plus sign in it. So you should have that symbol in the area for layer G, and then put a whole bunch of strikes and dips around the area for the rest of the layers. And of course, don't forget to label the ages and the rock types across the geological maps. Put the hinge lines in and a whole bunch of strikes and dips. And that should be it, following the instructions for this lab. Thank you very much. If you have any questions, call up Frank or Dave, and we can help walk you through some of the parts of this exercise.